Atoms are the smallest particle of any given element. You know what the elements are, or at least you know some of them. Uranium, gold, tin, aluminum, hydrogen. A lot of these are pretty familiar to us, and all of them make certain substances. So if you cut that in half, and you keep on doing that, is there any point at which you're no longer dealing with the same substance? And the answer, given what we know about the atom, is yes. Once you reach the size of the atom, if you cut that, you're no longer dealing with the same substance. Here's the periodic table. It shows that there are 118 different elements, and therefore 118 atom types. Only 98 of these are actually naturally occurring, and 10 of those 98 only occur in trace amounts. So 20 of these are completely synthetic, are only made by people in labs. Zoom in on an actual atom. Here's an image of an atom. Now, this could be a stand-in for any atom. There's a technical difference that I'm not going to go into in this video, but the electron clouds for different atoms actually look somewhat different. Here's a nucleus with an electron cloud around it. All atoms are made up of protons and electrons, and every single atom other than hydrogen has neutrons as well. Protons are pretty small particles, as are neutrons. Neutrons are just slightly bigger than protons by about 1/2000th. So you're dealing with protons and neutrons being roughly the same size, and that's considered one atomic mass unit. And electrons, which are about a 2,000th the size of a proton or a neutron, don't really figure in when we're trying to figure out the mass of an atom because it's so small. A typical hydrogen atom has two components, a proton and an electron. The proton sits in the center, in that dense little nucleus region, in the pink region, and the electron flits about in a cloud-like region around the nucleus. This atom, while it could be hydrogen with that proton in its nucleus and one electron flitting about that electron cloud, all atoms other than hydrogen are bigger than hydrogen, and they have more protons and electrons than hydrogen. And not only that, every atom above hydrogen has neutrons as well that make it weigh a lot more. So let's get back to the periodic table and get to know these different types of atoms a little better. The periodic table is our menu of matter in the universe. Now, it's not everything in the sense that there are subcomponents of this matter, and also this matter builds up into things that are very different than these individual components, but these are all of the base elements of the universe. The periodic table, to get a little comfortable in this space, is split into periods or horizontal rows. So the rows going across are called periods. And from left to right, vertically, they're ordered into groups. And you could actually see in this image 1, 2, 3 correspondingly left to right. On top of hydrogen, you see the number 1. On top of helium, on the far left, you see the number 18. And those are the 18 groups of the periodic table. There are many features of atoms that are conveyed through this table, but the most fundamental trend that we're going to see over here is the fundamental rule that governs atomic identity. What makes an atom of a given element is the specific number of protons that it has. Gold won't become not gold if I add an electron, or I add a neutron, or if I take away an electron, or I take away a neutron. But if I add one proton to its 79 protons, and you could see gold there by number 79, in column 11, row 6, the symbol is AU, and you have a 79 in the upper left corner, and that's the number of protons. If I add 1 to that, suddenly it has 80 protons, and that's going to move to the right to be Hg, mercury, not gold. Neutrons and electrons, on the other hand, are less crucial to atomic identity. For most atoms, if you add a couple of neutrons, you're still left with the same atom. Sometimes, if you add neutrons beyond the amount that the atom could take, one of those neutrons or multiple of those neutrons are going to convert into protons. And if it converts into protons, suddenly you have more protons and the element changes type. But you can generally add a number of neutrons to an atom with nothing changing, other than the atomic mass, the weight of the atom. And the same could be said for electrons. If you look at any of these elements and you add an electron or you take away an electron, that atom is still exactly the element that it was before. However, there is something that changes, which is the charge of the atom. Atoms are standardly neutral. If you add a neutron, that doesn't change anything because a neutron is neutral. If you take away a neutron, it doesn't change anything because it's still neutral. But for protons and electrons, that absolutely matters because protons are positively charged and electrons have a corresponding negative charge. A proton is a +1 charge and an electron is a -1 charge. And normally, atoms are equal. You're going to have the protons and the electrons are going to sum to 0. But sometimes atoms will be ionized, which means that it's charged in either direction, either negatively or positively. So if you take an electron off of a neutral atom, that atom now has more protons than electrons, so it's a positively charged particle, so it's ionized, and that's specifically called a cation. And vice versa, if you add an electron to a neutral atom, that's now going to have more electrons than protons. It's going to be a negatively charged particle, an ion, and that ion is called an anion. Now we're a little more comfortable with atoms. We know what atoms are, we know what makes their identity, how to change their identity, and how to change their charge. In the next video, we're going to take a deeper look at atoms. We're going to get to know them better. And after that, we can move on to the subatomic particles that make up the atoms. Until next time.